Welcome, everyone, and thanks for joining us for today's federal webinar, Unlock the Power of Vectra AI and the New Suricata Signature Engine. Before we begin with today's presentation, let's cover a few housekeeping items. This webinar is being recorded and will be sent out in a few days along with the presentation slides. Phones are muted and participants are encouraged to type questions into the Q&A tab. We will answer your questions throughout the presentation. We encourage you to download the resources available on your screen and follow us on social media for our latest and greatest updates. Without further ado, our speaker today is Brad Woodberg, Director of Product Management at Vectra AI. Brad, the floor is yours.
All right, thanks, Julie. Hi, everyone. My name is Brad Woodberg, as Julie mentioned. So I'm in charge of all of our AI technology here at Vectra, including all of the signature-based detection that we're here today to talk about. I've been with Vectra for a year and a half, and prior to that, I actually ran the emerging threats team. If you're familiar, emerging threats runs the signature set that pretty much everyone uses for Suricata. Spoke at Suricon several times, so this topic is near and dear to my heart, and I'm really excited to share what we've done here with you today. So let's dive right in. In terms of the agenda, we're going to talk about what Vectra Match is, why we did it, how it works, capabilities, use cases. We'll go into some information around the architecture and a little bit about kind of what we have planned and kind of how this compares competitively. So first off, what is Vectra Match? Vectra Match is essentially the combination of Vectra's AI technology that we already have in our platform as part of the Detect portfolio with Suricata, which is an open source IDS engine. If some of you maybe aren't familiar with it, it's kind of the de facto standard that everyone's using these days. Really replaces like legacy Snort, but brings a lot of those capabilities and much more. Now, there's some things that Suricata is really well geared towards, and we're going to go into those in a lot of details. But essentially, this is providing kind of a better together story between the best of both worlds with AI, along with some of the signature capabilities that a lot of customers still either want or need to have in their environment. So in terms of what Vectra Match brings to the table, the first thing is, we have natively integrated Suricata directly into the platform. So that's really important to call out because unlike certain other solutions out there that maybe are trying to do like an emulation layer or trying to transcribe signatures in the Suricata format to a proprietary engine, we're leveraging true Suricata here. So pretty much everything that runs in Suricata will work for us and work in the same manner that it does within Suricata, which you can run, if you're like testing or doing signature development, you can run that on your own and get the exact same results. Whereas, other solutions out there, your mileage may vary. So definitely a big advantage for anyone who, is doing their own signature development, but even from an operational perspective. Now, Suricata itself is bringing the ability for you to be able to provide your own signatures. You can leverage open source rule sets that are free. You can leverage commercial rule sets. You can get rules from maybe other industry partners or even other federal providers themselves. Since you can provide all of these, you have a lot of flexibility, which is really valuable in today's day and age. The alerts that we generate are going to be in the native Suricata format. So if you are running Suricata already, you can really just plug this in to replace whatever your existing source is. And we'll talk a little bit more about what that looks like from an architecture perspective, but you don't really need to change anything in terms of if you have like apps that are or scripts or other things that are processing the Suricata alert information, because we are producing this in its native format. There's really nothing that you would need to do. You can kind of swap us in and start getting the benefits of all the ML, the AI, and the metadata and alerts. Vectra Match and Suricata support IPv6. So we know a lot of folks in the federal environment have IPv6 requirements, so that's not a problem at all. It's really just natively supported right out of the gate. So there's nothing particularly special there, but we just wanted to call that out. Next, Vectra, we do support air-gapped deployments for our Detect for Network platform, and that includes Vectra Match. So We don't need any internet connection. We don't need any data flowing back to Vectra. It can run in a completely self-contained environment, and Vectra Match fully supports that. So that's a really nice benefit of being able to leverage this solution. And finally, the signature ecosystem has some real strengths when it comes to IoT and OT environments, and even the ability for you to craft your own signatures around like weapon systems and other types of proprietary applications. That's a big strength for Suricata. And there's a lot of, particularly on the IoT OT side, there's a lot of signatures that are already there, looking for known exploits, CVEs, other things that are threats to those types of compute resources. So you definitely can deploy this and start getting value instantly right out of the gate. Now, since Vectra, we've really been focused on AI, up until this point. It's pretty important to kind of call out like the differences between the value that AI brings versus signatures versus threat intel. So if we start kind of at the bottom of the pyramid here, you have the most kind of definitive objects, which is starting with a hash. Hash is an explicit fingerprint. It can't be modified at all, otherwise the fingerprint will change. So that could be something like like a SHA-256 hash or like a JA3 hash. Any changes are going to at least changes to the parts that are calculated is going to result in a difference in the hash itself. So it's typically more of a transient value, as we say. It can't be modified without changing its properties. And as you move up the chain to things like IPs and domains, those they take on a different element. Those are IPs are kind of a location, and a domain is a descriptor for the location. Those can change depending on who's operating them and what is happening behind them, or at least their status can change because an IP address can be owned, taken over by someone malicious and be returned to someone who isn't malicious. Typically, domains are a bit more disposable. As you go up the chain, but they still are artifacts which can be used to describe threats. Now, we already have threat intel, but what we've added is this signature layer, which is basically describing network artifacts. Now, these are typically, and we'll explore one a little bit later, but these are in the form of matching a pattern of bytes, a regular expression, if you will, of the network traffic to kind of label it and say, hey, this is a command and control channel. This is a known CVE. This application is vulnerable. It's an expressive way that's more portable than, say, a hash, because a hash is going to be whatever that object, that given object is, whereas a signature could describe any object that exhibits that pattern, right? That sends that pattern of traffic that matches the signature. And so they are more portable, but they still are a bit more deterministic. You're matching for kind of a specifically defined element. Now, at the very top of the pyramid is the AI-based models, and those differ. Even though the outcome of all these are kind of the same. You're trying to identify something malicious, but they are very different ways of describing those objects. With AI models, effectively, what we're looking for is behaviors. So rather than saying, hey, we're trying to identify a specific attribute or element, we're looking for the behavior that an attacker is going to be performing. For instance, if they are trying to exfiltrate data. Send data in bulk in any number of ways. As one example, you can't necessarily describe that with a hash, with an IP domain. Signatures are looking for specific patterns. So if the attacker isn't matching one of those patterns, it's more about the behavior itself. And so you can kind of see how all three of these different solutions really complement each other because they identify and describe, a different portion or attribute of a malicious attack. So, historically, up until this point, we have the threat intel, we have the AI, and now we're bringing in the signatures to kind of complete that chain. All right, perfect. All right, so now that we kind of described, what are some of the differences between, between signatures, threat intel, and AI? Why would you want to leverage Vectra Match? Well, first and foremost, it can help you to save budget and simplify your deployment, and you'll see why in more detail when we get to the architecture slide. But effectively, what we're able to do is kind of collapse disparate solutions into one platform that can deliver the AI, the metadata. We can deliver the signature-based matches, without having to change your network architecture, all in one platform. So this can definitely help you save money and budget, and certainly in this day and age, it's something that I'm sure your upper management would be happy to hear. When it comes to IDS, a lot of customers still have requirements for IDS. It may be a compliance requirement. It may be something that your internal teams, your SOC or the threat hunters and others require you to operate an IDS solution because it can be a good source of signal intelligence. And so now you don't have to make any trade-offs. You can run both these solutions in a single pane of glass. Given that you can also provide your own rules, and that there's a whole kind of wealth of signatures that are already out there that describe these known threats, signatures and Vectra Match are a really effective way to identify these threat vectors, simply by providing the signatures which are already readily available. You can identify the known threats, and then AI can help to pick up the things that maybe we haven't seen before. And lastly, by combining the signature technology into Vectra Match, we're able to cover a number of different use cases within customer deployment. So we already provide the MLAI. We're introducing the signature-based matching. We're able to generate metadata of every network transaction that you see, so that can be really useful for forensics and other purposes down the road. We already have integrations with things like SaaS providers, M365, Azure AD. We integrate with cloud, so you have both our control plane detections for AWS Azure control planes, but we also can plug our network sensors into those cloud environments. And lastly, we already have integration with 8 EDR vendors, and we're actually expanding that to be able to take advantage of some of the attack signal that's generated there. So when you factor in all those other elements, Vectra Match really plugs in nicely to identify the known threats that are out there, and complement the other parts of the portfolio.
Hey, Brad, we have a question.
Oh yeah, please.
How long does it take to enable the signature capability?
So it's actually quite simple. It just takes a minute or two. Since you'll see in the slide a moment, the architecture, essentially, there's no additional hardware or software components to deploy. All you have to do is just flip a switch and provide the signature. So you can have that up and running in just a couple minutes, and there's no changes to how you distribute traffic to Vectra or any additional components that you need to run.
Perfect. That's all for now. And as a reminder, if you have any questions, feel free to put them in the Q&A tab.
Excellent. All right, so in talking to our customers, we heard several things, that kind of drove us to want to build this, and those themes include the first one is compliance, security, incident response requirements. So I mentioned this a bit earlier, but we heard from a lot of our customers that there's some sort of compliance. It may be an external compliance, like a regulator. It may be an industry like PCI compliance. It may be something that your own internal teams do, or in some cases it could be business partners. I don't think that necessarily is the case for this audience, but certainly we've heard that from others. And a lot of this pertains to the coverage of vulnerabilities. so CVEs. We know that a lot of compliance programs basically require you to either be able to identify for every CVE how either you're not vulnerable to the CVE, how you may have been vulnerable, but you have patched, so you are no longer vulnerable, or you have a compensating control like Vectra Match, which enables you to identify if a vulnerability is being exercised or reconned or probed or whatever. And so the compliance angle is a really big driver. Next, we've heard from customers about threat hunting. So if you do have a threat hunters within your organization, being able to leverage Vectra Match as a signal intelligence source to be able to provide not only the metadata that you would get, but also kind of a labeled data set of threats that you see within your environment. That can be really good for if you're looking for indicators within the environment. So it can be used kind of in a proactive fashion. It can also be used in a reactive fashion as context enrichment. So if you have an incident, the audit level events that an IDS can identify can be really valuable. These are things that you wouldn't want to be looking at normally. You wouldn't want to investigate every time some of these signatures fire, but they can provide some really good context if you are doing an incident. And I'll give you an example. Like if someone downloads an executable from an IP address rather than from a domain name. That in and of itself is pretty simplistic, but it oftentimes indicates that, hey, something, this is a good indicator that something may have happened right here. So something that you can keep on the lookout for. And finally, we've heard from a lot of our customers that maybe they have IDS already. Maybe they run it at the network perimeter, but they want to be able to expand it into the network to be able to monitor for lateral threats. Maybe you already have IDS and you want just another vendor with a different, set of intelligence to be able to provide kind of defense in depth. And that is something that is very easy with Vectra Match because we basically plug right into the architecture, as we'll see here. So for those of you who are familiar, the Vectra deployment really has two components. You have the sensor and the brain. Now, the sensor is what you're going to mirror all the traffic to, and nothing changes at all there. All the traffic that you're sending before, there's no changes required. But essentially what we do is we carve off a small portion of the sensor to run Suricata. So effectively, we give Suricata its own hardware resources, its own CPU, memory, disk, and that way we can ensure that, even if regardless of what state Suricata was in, the rest of the platform can continue to proceed along. Now, Suricata is quite robust, so usually that isn't going to be a problem at all, but we wanted to design it with the maximum resiliency in mind. And essentially, we're copying the packets to Suricata within the architecture. So even if Suricata was busy, it won't impact any of the AI, any of the metadata generation at all. Now, the sensor is just where all the traffic is processed, and we're generating all the metadata. And now with Vectra Match, we're also generating the IDS alerts, which are flowing up through the system. And so we send those up to the brain, and from there we are able to send those on to your SIEM, SOAR, whatever you're leveraging. Today we support syslog, both encrypted, non-encrypted, TCP, and Kafka, encrypted, non-encrypted. So you can run that natively. Pretty much everyone supports syslog, and a lot of folks support Kafka. So this is able to plug into most deployments without any real changes. You're probably already doing this if you're a Vectra customer. Now, in terms of how the rules are managed, it's really simple. You have, essentially your client endpoint. This could be a virtual machine. It could be your desktop. It could be, some other container. And you upload the rule file to the Vectra Brain. So you have full control over what the rules are, what goes into it, your own rules, commercial rules, open source. You don't need to send any of these back to to Vectra. These can all be self-contained in your environment. And you just tell the brain, which sensor that you want to install the rule set on. You can install it on one or more sensors. You could do a rule set per sensor, or kind of any combination thereof. And that automatically gets managed and handed off to the sensors as you described. You can also pull information from the brain. What is the state, the health, alert stats, and those can kind of flow back right back to the client. So it really simplifies the administration of a Suricata deployment. If it's something that maybe you have already in a DIY fashion, you don't need to care and feed the operating system, or packages or software upgrades. You just provide us with the rules and tell us which sensor that you want them to go on, and you're good to go.
Hey, Brad, we have a couple questions.
Yeah, please.
What format does Vectra Match export syslog data in?
So basically Vectra Match, so there's the format and there's the kind of the protocol that you can do it over. So the format that we support is JSON. We support CEF, CEF. And we also support the standard fastlog or syslog format, which is just a really brief format. I have in a couple slides an example that I can show you of the JSON, which is quite detailed, and then we support sending it over both syslog and Kafka today, as I mentioned.
Perfect. One more question. Does Suricata support devices with mixed mode?
Yes. Yep. Yeah, we support Vectra Match. We support it on all sensors, so all physical, virtual, cloud, and you can run it in the standalone sensor mode or in mixed mode. And we publish all the performance information about the different ones.
Thank you.
Absolutely. So one of the really cool things about this is that you're as a customer, you're in control here. So first off, you can write your own signatures, as we talked about. You can leverage open source rule sets. You can leverage commercial rule sets, or really any that you would get from industry providers or any combination of the above. But another really valuable thing on top of the fact that you're in control of kind of what goes in content-wise is that you can actually see, what the contents are of the alerts, of the signatures. And the reason why that's valuable is if you have an alert, you're able to actually look and see, here's, the artifacts of that alert. How do those line up to the signature itself? And, I can use that to determine, is this a malicious true positive? Is this a false positive? Is this maybe a benign true positive? And that's very different from closed source IDSs, which is the vast majority on the market. You can't actually see the contents of the rules. So when there's something that fires, you just kind of have to, to trust the vendor. You don't really have any ability to see what made this traffic so interesting that the alert fired. With Vectra Match and Suricata, you have full control over the rules and certainly full visibility over the rules. So if we look here, this is just a sample rule that I pulled out of the ET rule set. The pink portion is basically looking at the network information. So this rule is matching from the internet coming inbound. The light pink color is describing like the signature title. So that's what would show up in your event log. The yellow portion is actually the signature, the pattern itself. That's describing when we see a PowerShell script being downloaded as part of through an iframe. So pretty suspicious stuff. If someone's trying to run a PowerShell script through an invisible frame of an interface, but attackers do it. And then the green portion is all metadata that is provided to enrich the user experience. So it doesn't impact the detection logic at all, but it basically describes additional context for analysts and administrators to understand, what is this signature actually matching? What are the contents? And so very, very valuable information, which is not only in the signature to be used when you're crafting a policy, but it also is included in the output of the alert. So this is just an example. Now, I should mention that you don't need to know what any of this means. You really don't. But for those who who do want to have that level of visibility and control, it's available, and it's once you get the hang of it, it's pretty straightforward to be able to efficiently look at this stuff and get to the bottom of it. So definitely a key advantage over closed source platforms. I just want to kind of call out, this is what an alert would look like. You can see they're very, very detailed. It's going to give you the full information about the network artifacts, the details about the connection. You have metadata describing the signature and kind of what it means. We can see in the top right, we have the DNS transaction, how many packets have flown in the different directions and bytes. And then at the very bottom right, you see information like payload printed, and packet. And so the Suricata alert actually includes the full packet trace of the packet that matched a given signature. So that's very, very valuable. In fact, you can take the packet payload and you can convert that into a PCAP. So you can actually view it in a tool like Wireshark. Again, we're sending this all out in the native Suricata format. You have really a high level of detail that can help you understand the context of this alert and all the enrichment and the packet data. It's all there for you. And because this is in a JSON format, right out of the box, it'll work with tools like Splunk or any kind of Elastic, whatever Steve you're using. Pretty much all of them will support JSON these days, and several of them also have applications, kind of built-in plugins or apps that can also process this. So I just wanted to kind of highlight the level of detail that you get when you have one of these alerts fire. It's pretty valuable. So we just released this functionality in the end of March release, our 7.6 release. So this is available now in the market. In the first release, as I mentioned, you have the engine supported on all sensors. You bring your own signature-based model, so you have full control over what gets loaded and the administration and management of it. You can configure the rules on a per-sensor basis. We have an API to be able to manage this, so that's super valuable because most customers are going to use automation for the daily rule set uploads. It's just literally a couple either curl commands, or we have a Python example, and yeah, it doesn't get much easier than the one we built, and it's really nice because again, you can automate all this stuff to ensure that you have daily daily updates or whenever those need to happen. So a human doesn't have to care and feed for this thing. It can self-contain, run a self-contained manner. The signature matches, we talked about the fact that those can be sent to Theme or SOAR by SSL and Kafka. So all that is included in this first release, and this is a licensed product. So as you'll see, we have a lot of things that we're working on enriching in the product going forward, and so we definitely want to make an investment here. So we are able to provide an eval license at no cost. You can do a full eval if you want to take this for a test spin. And again, because it runs on all form factors of the Vectra solution, you can run it in the lab, you can run it in virtual, no problem at all. The capabilities are the exact same. It's just the form factor and the performance that would vary.
Hi, Brad. Sorry, we have a couple questions.
Yeah, sure.
Do I have to use the same signatures on all sensors I have connected to the same brain?
No. You can configure a policy per sensor, so you're able to do that. You could create the equivalent of like groups of sensors that use the same policy and other groups that use different policies. You have full control to do that.
And then one more question: can you go more in depth about the conversion of the payload to a PCAP? Yeah,
absolutely. So let me just step one step back here. So we have this documented in our FAQ, and I'll provide a link to that. There's a tool out there called I think it's Eve to JSON that you just import the Suricata alert, and it'll spit it out as a PCAP. It'll automatically parse it, extract out the packet information, and put it in PCAP format, and there's just a one-line operation that you can do, and then you have a PCAP that you can load in your favorite packet capture tool. Now, this will have, the information today will be whatever was the matching criteria. We are looking at things in the future to be able to extend that beyond just the payload that matched a given signature. But the really valuable thing here is that, if you're trying to better understand, like, is this a true positive? What was the context that this thing happened? This information is automatically generated, so it'll match on exactly what Suricata used to say that, hey, this is a signature match.
Awesome. And how many rules can be used at a time?
Great question. So there's not a strict limit. We have loaded the full ET Pro rule set, which is 100,000 rules, without any issue at all. I think that there's plenty more capacity. So I suppose the only limit that we have today would just be the maximum file size on disk, which is around 200 megabyte. Right now, the ET Pro rule set is like 55 megabytes. So it seems like we have more capacity to go. The thing I've noticed, and I've spoken at Suricon on a number of occasions, when it comes to the number of rules, the performance isn't really so much impacted by strictly the number of rules. It's really the rules themselves, the content that you're matching that's going to actually impact performance. 10,000 well-written rules will have less impact than one poorly written rule. So we do have, and I think it's also, it is referenced in this presentation, we do have a knowledge base article that kind of talks about the performance and tuning and things like that, that can also be referenced. I know we'll be sharing these slides to follow.
Perfect. That's all for now.
Okay. All right, excellent. Please keep them coming. So we talked about what we just released in Q1, and then let's talk about what we have coming in this quarter. So we're working on integrating our host ID support. Host ID is really, it's a differentiator for Vectra. Essentially, we're able to identify a host throughout its life cycle on the network. So, on a day-to-day basis and over time. So, for instance, if you were to log in via VPN in the morning, and then you go to building A, and then you go to building B, and then maybe you go to a coffee shop, and you go home, and you connect back on the VPN, you could easily have a dozen different IP addresses. And so, traditional IDS, the onus is going to be on the operator to figure out, where was the user at every single stage of their day, so that you can properly stitch together the events that happened to be able to, really identify a full incident. And that can be a lot of work, again, especially these days. It's not like a couple decades ago where everything was going to be a fixed workstation that had the same IP, same location all the time. These things are going to move around considerably. So host ID is something that we already have built in that powers our AI detections. You see those in the UI, in the in the syslog alerts that we generate. But we're going to start enriching the Suricata information, the Suricata alerts, with this as well. So now you'll be able to key just in on those host ID identifiers, and that way you can kind of follow a host regardless of what IP addresses or where it moves around. Next, we're adding in the web UI for management coming this quarter. So today, as I mentioned, you have the API, which really is what most people are going to be using on a day-to-day basis, but we wanted to extend that out, and also include web UI support, especially if you're setting this up for the first time. We're working on an enhancement to the Vectra app, so for Splunk, and then we're also looking at some other other ones as well. We do support things like Sentinel and QRadar and a few others, so we're going to look at enriching those. The cool thing is that Vectra Match, because we're setting this in the native Suricata format, there's really nothing that you need to to do, but by leveraging an app, it can provide more of a customized user experience, which is valuable. All right, so we talked about how Vectra Match works, the why you use it, the architecture. Let's talk about kind of how we stack up against the competition. So I really kind of divide this into two different areas. The first is Corelight. Now, Corelight is basically, they're the folks who build Zeek. Not a lot of respect for them, but essentially they're just running Suricata plus Zeek. They don't really have much in the way of the AI. They don't have anything for cloud control plane or SaaS. You can run a virtual sense in the cloud, but they're not going to protect your cloud estate. They don't have the prioritization framework, and I would also add they have a relatively weak host ID implementation, so you're going to be spending a majority of your time having to sift through alerts and trying to stitch things together, where all those things are kind of brought to the fore as part of what we get out of the box. Now, Suricata itself, we know a lot of folks that run Suricata. Obviously, Suricata we think very highly of. We integrated it, but there are some challenges if you're doing DIY. Suricata in and of itself is going to provide great signature engine, but it's not going to provide the AI. It's not going to provide the cloud control plane or SaaS support. It can definitely be more expensive to operate as an open source package. You're saving money on the license, but you're paying money in operations, and it does require some expertise to be able to care and feed every day. And so by leveraging a turnkey solution, you're able to really get more value out of it. As I mentioned also, because this runs right in your existing deployment, if you're running Suricata separately, it'd be a whole nother set of resources that you'd have to deploy and maintain, whereas you can do that all in one turnkey solution here. And lastly, there's a lot of standalone IDS vendors that are out there. What we've heard from our customers is that these are typically very expensive. They don't have any of the AI or the metadata capabilities that you're going to get out of a solution like Vectra. They're not going to have any cloud control plane or SaaS support, and a lot of times these solutions have really lost. The vendors that build them are not making any kind of significant investments in those products. They are just doing the bare minimum to keep them, as supported platforms, and there really isn't much innovation. There's not going to be much desire from a vendor to be able to take customer feedback and make meaningful change to a platform. So these are typically a great target as well to be able to replace with something where you do have that vendor commitment that you are delivering on those other use cases to be able to tackle the most current threats. And then finally, when it comes to some of the traditional NDR vendors, if you look at like ExtraHop, they don't really have any true signature capability, just this JavaScript language to try to match on metadata. They require the cloud, so they can't really run in an air-gapped fashion, which is typically a big problem for federal customers, and you can really only run the ML on critical assets. So they can support on their largest platform something like 16,000 endpoints, whereas Vectra can support on a single deployment 300,000, if not more. So you don't have to trade off with saying, hey, something is critical or not. So therefore it does get AI with Vectra. We have a very scalable implementation that can handle all that. And then on the Darktrace side, they really don't have any kind of signature capabilities. They have a capability to write queries and kind of custom expressions, but that isn't the same as doing actual signature-based matching. And certainly we've heard from a lot of our customers that the machine learning is very like rudimentary. The customers have to build a lot of their own detections out of the box based on different conditions, and it kind of turns you into needing to be a data scientist rather than being able to deploy a turnkey solution. So, we think that not only do we have something really compelling when it comes to AI, but also now that we're integrating signatures, we can solve those other use cases and help simplify your deployment, save money. Now, as we wrap up, we have a lot of resources, and we'll be sharing these with you. We have your traditional collateral. We have a deployment guide that goes through exactly how to deploy this step by step. We have a video that's just a couple minutes long that you can watch where we set it up and run some tests and show the output. We have collateral and our knowledge base that we're keeping well up to date. A knowledge-based article for FAQ, for kind of troubleshooting, for performance, and for the config that we leverage just as a reference. All this stuff is available, and we're keeping you up to date basically on a very frequent basis as we're rolling out new features and functionality, and as we get great new questions and suggestions from customers like you. And with that, that's what I had here for today. So we can stop sharing, and we can take some questions if there's any more that we have here.
Yeah. So what are some next steps that folks shall do if they would like to get this implemented?
Yeah. So it's really quite straightforward. You can just reach out to your either your partner or your Vectra account team and tell them, hey, I want to try out Vectra Match. All we need to do is just have that, and we can enable the Vectra Match license at no cost, so you can test out for a period of time. You can also go and just read through the deployment guide or watch the video or read through any of the collateral in the meantime to get some additional color on what's required. But again, it's pretty straightforward, and it's getting better and better every day. Here at Vectra, we do 11 feature releases a year. So that's not counting things like bug fixes, but that's just saying 11 months. We combine November and December just because of all the holidays and New Year's. But 11 of the 12 months, we have new features and functionality that's coming out that you get to take advantage of directly. So we have a really, really active development roadmap and a lot of great stuff that's just coming out constantly. So we're excited to be able to share that.
Fantastic. Can I use AI to create signatures?
Can use AI to create signatures. So it depends. Actually, I was just playing. It depends on what specifically you mean. Could you use, for instance, like ChatGPT to create signatures? The answer is yes. I was playing around with it the other day, and it wasn't bad. I mean, again, I ran the emerging threats team that writes all the signatures. I ran for 6 years. So I know quite a bit about writing them, and I think you can use ChatGPT to write signatures. I haven't tried like giving it a malware sample and saying, "Hey, go write a signature on that." I'm not so sure it can do that, but I was able to describe what I wanted, and it could write that right there. And then of course the AI. We have a lot of AI that comes right out of the box, so. There's nothing that you need to do other than plug us in and tell us what networks are your internal networks, for instance, before you can take advantage of this solution. So you get the AI right out of the box, and then you can enrich this with your own signatures. But yeah, if you meant something else, please add another comment in there. But yeah, like I said, I was playing around with ChatGPT. The other cool thing is that there are, there's the whole ET open rule set. I think that there's something like, I don't know what the exact number is now. It's probably at least like 50,000 or so rules in that. And then you have the commercial version, which basically is ET open plus the Proofpoint proprietary ones. But they're all open. You can view the patterns in those, and all that is available. So, really the signatures that you would write, it would typically be something where it's a proprietary application or a proprietary concern that you have specifically for your environment.
Awesome. And someone said that you mentioned a tool that you used, but I'm not sure in what context of when you were using that tool. I don't know if you know.
Yeah. So, I think the question was, how do you convert the payload, the text-based payload into a packet capture that you can run in Wireshark? The tool, and it's in our FAQ, so we'll share this. You can get a link to that. But the tool is called Eid to JSON, and it can take in Suricata alerts and output packet captures right from that. So take the text in and output that. So I think that's probably what you're referring to. But if not, just put another note in the QA, and I can answer that. But yeah, we have reference to that in our knowledge base articles.
Perfect. And I think that looks like that's all the questions that we have coming in. Do you want to provide us with any last minute nuggets of gold that you have for us? And if not, we can just wrap things up.
Yeah. I mean, let's definitely. I think it's always great to end a meeting a little bit early. But just really want to thank everyone for your time today. This is something that we're really, really, really excited about here at Vectra. We have a robust set of new functionality that we have a robust set of functionality that we've already delivered, and every month that's going to get better and better. We're working on some of the longer term deliverables here, but I'd really invite you to try it. And all you need to do is just contact your partner or your account team, and we can get you that license. There's no additional hardware components to deploy. There's no network changes that you need to do. It really is a plug and play solution, and we think it can help simplify your deployment, hopefully save you some budget and complexity, and enable you to work faster and smarter. So if you have any other questions, if you think of any after the fact, just contact your Vectra resource. Be happy to meet if you want to have me come in and chat with yourself or the team, or if you have other questions, we'd be happy to engage. So thank you, everyone, and happy to give you 10 minutes of your day back.
Awesome. Thank you so much, Brad. Brad's contact information is on the upper right-hand corner of your screen. It's his email and his LinkedIn, so feel free to connect with him if you have any specific questions for him. Again, thank you for your time today. We hope you found this content beneficial. Again, the recording will be sent out in a few days along with the slides, and a member from our federal team will connect with you soon. In the meantime, feel free to download the resources available on your screen, and we look forward to seeing you at our next event. Thank you, everybody.